This lesson is a high-level overview of the basics of fuel trims. This subject can be made more complicated and there are a lot more things to understand. I'm trying to cover the very basic foundations of fuel trims so you can build upon that. If you don't know about fuel trims or you don't understand them, be sure to watch this. And also at the end of this lesson, the next lesson, if you're on the membership site, there is a PDF download that you can do to follow along and just record your findings. I want you to start testing vehicles yourself and see what you find. If we learn what good is, bad will stick out like a sore thumb every time. In my daily adventures, the biggest frustration that I see technicians having, next to a lack of understanding of basic electricity and voltage drop testing, is a lack of understanding about fuel trims. Fuel trims are something that's really, really easy for us to get a grasp on. It's really not that hard. I'm going to cover what you need to know, and also I'm going to do my best to explain this in a way that I wish somebody would have showed me many years ago. In this lesson, we're going to talk about how this can help you. We're going to define fuel trims. We're going to talk about what they do and how they do it. And I have some demonstrations, one on-vehicle demonstration and something a little quirky that you may have never seen before that hopefully will get you to understand fuel trims in a very easy way. How can this help you? Fuel trims, having understanding of fuel trims can get us an idea of what the computer is trying to do to make the vehicle run properly. That's what fuel trims are. We're getting an inside look at what the computer is doing to make the engine run properly. That's so simple. That's a simple definition. But this can really help in drivability diagnostics. If we ever have a bank-to-bank imbalance and our fuel trims are looking different from one bank of the engine to another, like in a V-style engine, we can pretty quickly come to the conclusion it could be a cam timing issue. For a V-bank overhead cam engine, could be a restricted exhaust. Anything that's going to affect the one bank versus the other. If you're dealing with a misfire condition and you're trying to figure out, well, is it an injector or is it a coil? Fuel trims can help you determine that. Understanding what the fuel trims are and how they work can make a big difference in your diagnosis. As many other instructors have said, and I agree 100%, and I go by this too, we got to go for the low-hanging fruit. What's easy for me to look at without getting dirty, without having to take apart the car, and fuel trims are one of those things that give us easy access to determine what's going on with an engine. Now this is just another tool in your belt to help you diagnose a vehicle. When we go ahead and define the word trim, we're talking about fuel trim definition. Let's work on the word trim. What is the definition of trim? If we think about trimming the sails on a boat, what are you doing? You're going to pull in the sail or tighten up or whatever. I'm not a sail person much. I enjoy sailing, but I'm not the sailor, right? But you got to trim your sails. We're adjusting the sails for the best performance of that boat, okay? What about when we're talking about elevator trim on an aircraft? If you've ever played like a flight simulator video game where you have to fly an airplane, if it's not a true toy game, if it's an actual real simulator, you're going to find, depending on the airspeed of the aircraft and the pitch that you want to maintain and the power level and all these other inputs, you have to adjust the trim. On a little Cessna, it's a little wheel you spin like this up or down to adjust the trim, so you get to the point where you can let go of the control yoke or the stick of the aircraft and the aircraft will fly straight. I almost said vehicle, right? The aircraft will fly straight and level if you let go of the control stick. And that is trimmed, okay? That's your elevator trim. If you're always having to push down on this stick to keep the airplane from going up, if you let go of the control yoke and the airplane goes up, well, you're always pushing down. Well, you've got to trim that elevator so that you take pressure off the controls so that the plane flies straight. In electronics, you may find something called a trim pot. It's a trim potentiometer that you can adjust the resistance to a certain value. That's adjusting the trim. Take a look at this RC car. There's a steering trim adjustment on the controls of it. Now, why do you think we have this trim adjustment? Well, I'll tell you what. In a perfect world, with the wheel straight ahead, which this thing self-centers, the vehicle will go straight down the road. But what happens is, life happens. We bang into curbs. Nothing is quite as it should be. Things get out of whack. That's why we have this trim adjustment here to make adjustments. Take a look at this. With our steering wheel straight ahead, you see this, and our trim about to zero, we're going to go ahead and drive this and see what happens. Well, we have a problem. Let's back this up. Let's try this again. Let's make an adjustment to our trim here, like this. Now the vehicle's going pretty straight. I still have to make a minor input. I still have to make minor corrections to my steering input, but look at this, it's going pretty straight. Every once in a while I gotta tap it, and we're going straight down the road. Now here's where the lesson comes into play. Our long term follows our short term, okay? So if I start driving down the road, from the factory, this vehicle should go straight, but it doesn't. So my short term has to hold the wheel. I'm holding my short term or making minor corrections all the time to my short term. And I get tired of doing this. I don't want to have to do this all the time. It makes the job hard for me, right? So I make a minor correction. So I need to make a minor correction to my long term, and now I have to make less of an adjustment to my short term. The goal of the engine computer is to have the short term close to zero. So we're going to keep on going here, and sooner or later, I'm going to overcorrect. Look, if I turn my trim all the way to the right, having my trim all the way to the right, now we've overcorrected, so we got to back off our long term just a little bit. All right, I think it's safe to say that in a perfect world, with this trim at zero and this wheel centers itself, this would be zero short term and zero long term. As I start to go here, you can see this vehicle's pulling hard to the left. So I have to add some right long term, because I gotta keep on adding this right short term all the time. I get tired of adding right short term. I gotta add some right long term. Now when I go, I have less of a correction for my short term. I'm just tapping this wheel and we're going pretty straight. Still a little bit to the left, so I want to add some right trim. What we just witnessed here was a feedback system, okay? We had this RC car going down the road and we saw an output that we didn't like. It was going off the road, so we had to make a trim to the input to make the correction that we wanted so the vehicle goes straight. Guys, this is a very simple way of just talking about trims. Now when we get into talking about fuel trims, we're talking about making our engine control module have the ability to look at the exhaust in closed loop. We're going to look at the exhaust either with a O2 sensor or an air fuel sensor. I'm not so concerned with what type of sensor, but we're looking at the condition of the exhaust. Is it rich or is it lean? And we're going to make a correction, a trim adjustment to our input to get the output that we desire there. If we had a lean exhaust, our computer would have to add fuel to the normal correction. The normal correction would be zero. We have a lean exhaust. We're going to have to add fuel. That would be a positive fuel trim correction. If we had a rich exhaust, that would be, say, like a leaky fuel injector or something like that, or a leaky fuel pressure regulator on an older vehicle. So we have an overly rich exhaust. The engine control module would have to take fuel away. We would see a negative fuel trim number. So anytime we're talking about our fuel trims, short term and long term, if we start a vehicle up and everything's running perfectly, okay, when this vehicle's brand new and all the parameters are perfect, there's no carbon on the valves, we don't have a fuel pump that's running a little bit slow, we don't have any restrictions in the exhaust, the air filter's not dirty, there's about a bazillion things we can take out of the equation, okay? There's all these little things that make changes to how the engine will run. Engineers do their best to run a vehicle in every single condition that we can think of, and they use computer models and all kinds of stuff to calculate the proper amount of fuel for any load, any temperature, any RPM, or what have you. There's a bunch of things that go into play here. So they have a baseline zero. Now zero is going to be right in front of me, right at this camera, okay? So we start this car up, and I don't care if you say your long term's on top, short term's on top, it doesn't matter. The two values, if we have +5 long term and 0 short term, that's the same as having +5 short term and 0 long term. It doesn't matter. Long term doesn't mean we're adding more fuel than short term. Long term is just telling us, hey, we had to make this correction over a longer period of time. So we start the vehicle up on a good running day. Short term and long term will be right here, right next to each other, okay? And if we're running one way, I don't care, let's just not use any positive or negative. Let's just say short term has to go this way to maintain the proper operation of the vehicle. So short term kind of goes over here and it starts hovering over here. And long term is going to go over and catch up. As long term goes to catch up to the short term will come back to 0. Now the short term is always wiggling back and forth. You're always going to see it making quick adjustments. And long term is going to be real slow to adjust. That's why it's called long. Long term takes a long time to adjust. Short term takes a very short time to adjust. It's that simple. Let's go ahead and take a look at a chart. In the middle we have 0. At one end we have +25. And the other end we have -25. We have 5 increment divisions. If we're looking at total fuel trim, a perfectly running vehicle would have the fuel trim at 0 where this red dot is. If we have a vehicle that has a lean exhaust condition, we would have to add more fuel. Okay, so if the ECM detects the exhaust is lean, we're going to have to add fuel, and you're going to see this little red dot start to go more positive. Okay, so in this example, we're at plus 10. If we have a really lean exhaust, we'll have to go to plus 25. And on some vehicles, that may be maxed out for the fuel trim. If we have a rich exhaust, we would have to go negative fuel trim. Here we are around negative 10. If we have a very rich exhaust, we'd have to go to negative 25. So this is just an example of total fuel trim. Now we have to talk about how do we get our total fuel trim. This is really important to understand. We get our total fuel trim by adding our short-term plus our long-term fuel trim. It's that easy. Total fuel trim is equal to the sum of short-term plus long-term. Now where it gets confusing, and I see many people get messed up, is they get their banks messed up. So if you have bank 1, you have to keep that separate from bank 2. Short-term fuel trim bank 1 plus long-term fuel trim bank 1 equals total fuel trim for bank 1. Let's take a look at how this works. Here is the same chart we had before, but we added another line segment to it. On the top, we're going to have our short-term fuel trim, and we're also going to have, for this time, we're going to have a little bubble in the middle for 0. And on the bottom, we have our long-term fuel trim that's at 0 as well. Now, on a vehicle that's running perfectly in a perfect world, you're going to see these long-term and short-term be right at 0. We're always kind of like, that's the ultimate goal, okay? Now, if we have a vehicle that's running lean, the exhaust is lean, the computer is going to make an immediate adjustment to the short-term fuel trim. You may not see the long-term follow the short-term for quite some time, but if we have a vehicle that started running lean, you're going to have your short-term go positive. In this example, we'll say it's going to positive 20. So right now, our total fuel trim is equal to our short-term plus our long-term. So 20 short-term plus 0 long-term is equal to 20. So we have a total fuel trim correction of plus 20 right now. Now, after a period of time, the long-term fuel trim will start to adjust to make the short-term fuel trim come back to 0. What's going on here is the computer is trying to make the short-term fuel trim have a adjustment that's real close to 0 as the long-term makes up the difference, if you will. But if you think about it, look here. At any given point, we can take our long-term plus our short-term and get our total fuel correction. At this point, I had stopped it at short-term fuel trim plus 10, long-term fuel trim plus 10, so 10 plus 10 is 20. We still have the same total correction as before. And as time goes on here, you can see this chart keeps on moving, and our short-term gets real close to 0 again, and our long-term is up to positive 20. So a short-term of 0 plus a long-term of 20 equals the same positive 20 of fuel trim correction. Keep this in mind as we take a look at a real vehicle here. All right, everybody, I want to show you our setup for this live demonstration here. Here we can see that we have a fuel pressure gauge hooked up, and this is in line to our fuel rail down there. Now on this setup, I do have a valve that I can turn on and off. This would be off all the way, and this would be on, so I can actually block pressure to our fuel rail. Anytime we're dealing with any fuel, disconnecting a fuel system or anything, or even in our shop in general, we should always have a fire extinguisher. You always want to make sure your dial is in the green there. That is the important part. Here we have our scanner hooked up. This is in OBD2 generic mode. You just saw me say that we're using a generic scan tool. A generic scan tool will give you the fuel trim information you need to be able to diagnose a vehicle. That's no problem. Now, you can go into enhanced data if you like, but here's the thing. Enhanced data on some manufacturers can cause a problem. Personally, I've seen with Nissans and Infinitis issues using the enhanced data where I'll get skewed fuel trim data, and this will cause me a great deal of issues when I'm trying to diagnose the vehicle. So when in doubt, just check generic OBD2. I would recommend, as you're checking vehicles in the near future, just start looking at generic OBD2 data. It's just fine. This is in OBD2 generic mode. Let's go ahead and take a look at the data PIDs that we want to look at. I want to look at our fuel system status, which says OL, that means open loop. I want to look at short-term bank 1, short-term bank 2, long-term bank 1, and long-term bank 2. And we're just going to go ahead and display these data PIDs. I think these would be just plenty for what we're doing here. We also have a oscilloscope hooked up, and this is probed into our fuel injector control circuit for injector number 1. It's back probed in there so we can watch the injector pattern here. Now I'm going to go ahead and start this up. And we're taking a look at what's going on here. I want to pay attention to our fuel system status. Right now it says open loop. And you can see we have fuel trims. Now you can see it went into closed loop. So let's just watch what happens here as this engine kind of goes through. Right now our short-term fuel trim for bank 1 is about 10%. Our long-term fuel trim for bank 1 is about 1.6%. We can add those two values together. The 10 plus the 2, or 10 plus the 1 would be about 11, right? About 11%. So we're adding about 11% correction right now. You just want to add your short terms and your long terms together, and that's what you get. You keep them bank to bank. So this is slowly going down as the engine warms up or runs here. So short term right now is at 5, long terms at 2. So we're still adding about 7% total correction. And bank 2 is about just a little bit less. This is about 4%, 4 or 5%, and this is 1.6. So we'll let this run for a second and see what happens. Now after this engine warmed up a little bit and idled down, you can see we're about, about 3.9, 3.7, 4.7. Let's say 4.7 plus 2.3. It's about a total correction of 7% for bank 1. For bank 2, our short term is 4.7, our long term is about 1.6. So we have a total correction of about, 6 point something percent. Now I want to show you guys something here. Watch what happens to our fuel trims. Watch what happens to our short term for bank 2 and bank 1, which are over here, and our long terms are over here. Watch what happens to our short terms as I kind of put a little bit of a restriction in our fuel system. You're going to start to see our fuel pressure start to drop a little bit. As the fuel pressure starts to drop, watch what happens to this short term. Our fuel pressure is going down, and our short term's climbing. Our long term isn't climbing at all. But if I add the fuel back in, you can see the short term goes right back down. Our long term didn't change one bit, but our short term was changing. Now if I go ahead and create this restriction for a little bit of a time here, let me go ahead and add that restriction back. I'm turning that valve to close it just a little bit. I'm creating a little bit of a restriction here. I'm going to try and make it so we maintain probably about 40 pounds instead of the 55 or so that we had. So I created a restriction to maintain right about 40 psi. Keep an eye on our short term in bank 1 and bank 2, and our long term bank 1 and bank 2. I'll start a stopwatch right now, and you're going to see over a period of time this long term will start to add. And we're about a minute in, and there's no change in our long term yet. But you can see our short term is at 16% or so. Let's just say 16% plus the 2.3. That'd be a total correction of about 18%. All of a sudden, our long-term fuel trim, and this is about a minute and 20 seconds in, our long-term fuel trim starting to climb. Watch what happens to our long-term fuel trim. It's going to climb up, and our short term is going to back off. But we're going to maintain a total correction of about that 18% or so. 5.5 plus 12.5 is 18%. So we're going to maintain this 18% between our total fuel trim, because our total fuel trim is adding the two fuel trims together. So it's been about a minute and 52 seconds here, and you can see our long-term fuel trims are going up. This is the key to understanding this. We have this adjustment, a total fuel trim correction of about 18% or so. Now our short term went over to 18% or 16%, and our long term was over here. And just like we showed you with those little dots, as the fuel trims change, we're going to maintain our total fuel trim correction all the time. And our short terms are going down. The short term fuel trim is what went way over positive, and then a long term fuel trim had to come back so the short term fuel trim could come back down to 0. The computer's trying to make that short-term fuel trim be 0, but to make short-term fuel trim be 0, we have to get our long-term up there. So you're going to see it's going to keep on adding this fuel over a period of time, or adding the correction for the long-term for bank 1 and bank 2, and our short-term starting to go down. Now this is all because we're about 15 pounds less fuel pressure than the vehicle is expecting, or the engine computer is expecting. Now this has been about 4 minutes and 30 seconds of run time here for the long term to get up to this around 14% or so. And you can see our short terms are kind of closer to what they were before, really close to zero, just a couple percent above. Now if I go ahead and open this valve, watch what happens. The fuel pressure is going to go up, and you're going to see our short term is going to have to go way negative because our long term is so long. I'm going to go ahead and hit that right now. So ready, 3, 2, 1. Look at our short term. Our short term correction is going way down. We added full fuel pressure to this vehicle, so our short terms are way negative here. So right now the short term went way negative, and the long term is going to have to go negative until the short term can go back to zero. So look at this. Before, when we first started the vehicle up, we said we had about maybe 6 or 7% correction. -6 plus +14 is +8, right? -6 plus +12.5 is about +6.5. Now as this goes ahead and gets itself back to zero here, let's take a look at the same time we're doing this. Let's take a look at our fuel injector pattern. So what's really interesting is looking at our fuel injector pattern. If we take the fuel away, if we go ahead back again and start making a restriction in this, you're going to see this pattern. The on time of this injector is going to open up. So I'm going to go ahead and do that real quick. I'm going to cut this fuel, watch the fuel pressure gauge. And you see our short-term fuel trims are way positive, and our long-term's way positive. We're really creating a restriction. We only got 30 pounds of pressure here. Let me go ahead and put a cursor out here. In generic OBD2, there is not an injector on time listed for this vehicle. So if you went into enhance, you'd be able to see the injector on time, and it's measured in milliseconds. Now what we're seeing here is this pattern is opening up. There's more on time, so more time for fuel to flow into the engine here. We got our two cursors there, and we're measuring about an on time of 3.17 milliseconds. And look at our short-term fuel trim. We're down to about 18 pounds of pressure. This is adding fuel like crazy. Now watch what happens if I go ahead and turn this fuel back on. Do you see how that pattern got shorter? Because that little bit of difference in on time is the computer making the difference in fueling that's required. So there you have it. That was a high-level overview of fuel trims. This is a foundation of building your knowledge and understanding so you can go deeper into understanding, well, why is an engine running lean? Why is it running rich? But we can look at the fuel trims and understand that, yes, it is running richer than it's expected to, or it's running leaner than it's expected to, just by figuring out our total fuel trims. Here's a little worksheet I made. You guys can go ahead and download this right from the membership website as in the next lesson. And go ahead and start in your daily routine filling out this sheet. This is just checking for fuel trims in park on vehicles. If you're not a member of the Hands-On Auto Training website, be sure to check it out. Thanks a lot for taking the time to watch. Let me know what you think about this in the comments. You guys have a great day. Bye-bye.